Okay, so for question 1, we are given a chemical reaction and we're asked to find the molar enthalpy of combustion for sucrose. So here's sucrose, and we're asked to find what is the molar enthalpy of sucrose. So when we're setting up questions like this involving a calorimeter, we have to remember that the enthalpy change of the system is equivalent to the energy gained or lost by the surroundings. Okay, so our molar enthalpy of the system equals Q of the surroundings. So from this, we can set up this formula. So if I have number of moles times the molar enthalpy of substance is equal to the enthalpy of a system, I can replace this with Q, or MC delta T. Okay, so this means the MC delta T is referring to the surroundings in the calorimeter, which usually is going to be water. For the most part in calorimeters, we're talking about water being the surroundings. So if I substitute in my values for the surroundings, the mass is going to be the mass of water. So it's 250.0 grams times the C value of water, which is 4.19 joules per gram degree Celsius, and the temperature change is 55.5 degrees Celsius. So if we look at our units here, grams will cancel, degrees Celsius will cancel, then we'll be left with our answer in joules. So we're going to get a pretty big number here. Okay, our number is going to be, okay, so we're going to get, when we simplify this, we're going to get quite a large value. It's going to be okay, we're going to get about 58,136 joules. So 58,136.25 joules. Okay, we're looking for the molar enthalpy. So we want our units to end up being kilojoules per mole. Okay, kilojoules per mole. So my number of moles here is the moles of the sucrose. Okay, and I'm solving for the molar enthalpy. So I've got 58,136.25 joules. If I substitute in the value for the moles of sucrose here, which is 0.015 moles, okay, and I divide this by number of moles, okay, we get our final answer to be very, very large. It's 3,875,750 joules per mole. Okay. However, we want to convert this to kilojoules. So we can move our decimal 3 spaces to the left to convert to kilojoules. So we'll have 3,875. The original question, we're only going to want 3 significant digits. So we have to use scientific notation here. So this will be 3.88 times 10 to the 3 kilojoules per mole. If we go back to the answers given, the answer should be negative here because this is an exothermic reaction. So our correct answer is D.